Okay, so if I have a nonlinear system, a system that has at least one of them is not a line, what do I do then? Well, same two methods can apply here. So yeah, let's say we have this system, 2x squared minus 3y equals 23, and y equals 2x minus 5. And I want to solve that system. Well, what might you suggest to solve that system? What is this one set up for? Looks like a substitution, doesn't it? I've got y equals 2x minus 5, and so I've got something that I can replace y by in the other equation. So this one looks like it's tailor-made for substitution. Just substitute the y to be 2x minus 5 in the other one. And so that'll give me 2x squared minus 3 times 2x minus 5 equals 23, right? Just plugging in y to be 2x minus 5. And you have to do a little distributing there. 2x squared would be minus 6x plus 15 equals 23. Now, that sets up this equation to solve. What do we got to do to solve that? It's a quadratic, factoring or quadratic formula, possibly, if I don't exactly see the factoring. But yeah, this one looks like we need to make one side 0, don't I? Subtract the 23, make it 2x squared minus 6x minus 8 equals 0. And if they all have a common factor here, we can divide both sides by that common factor, which in this case is 2, and make it x squared minus 3x minus 4 equals 0, and that can help us solve it. Yeah, it looks like that one does factor. X squared, so it's x and x, minus 4, minus 3 in the middle, minus 4 and positive 1. Which gives me 2 equations of x. So add 4, you got x is 4. Subtract 1, you got x is negative 1. Now, not quite done, because we're talking about solutions to a system. And so I need an x and a y, don't I? And so these are the x, so I need to pair them with the y. Now, in this particular case, you would want, obviously, to go back to this one to figure out what y is. So y is 2x minus 5, so here we'd have y equals 2 times 4 minus 5, which would be 3, 8 minus 5. And then the x is negative 1 to figure out the other one. It's negative 2 minus 5, so that's negative 7. So yeah, here's another one where we have two solutions. We've got 4, 3, and negative 1, negative 7. And so that's what can happen on nonlinear systems. You get more than one answer. You may just have one. Still could have none, but probably going to get more than one. All right, here's another one. 3x squared plus 5y squared equals 14. And 2x squared minus 3y squared equals 3. 3x squared plus 5y squared equals 14, 2x squared minus 3y. Okay, so yeah, we've got a little more complicated still yet. What is that one looking like, probably to you? Elimination or substitution? Probably elimination, yeah. That's not going to be hard. That's going to be a hard one to figure out. Solve for one of the variables. Yeah, so this one, this one's probably our elimination method. But yeah, we still can use that on squared equations like this. So same idea. I would need to get either the x's or y's eliminated. Now, it's your choice. Probably I would go with the y's here because we've already got the opposite signs. But we could do the x's. It'd be smaller numbers, I guess, if we did that. But I'm going to eliminate the y's. y squared. So I'd multiply, let's rewrite it here. So the top equation, I would need to make them both 15. So I'd multiply the top equation by 3, make it 9x squared plus 15y squared is 42. And then the bottom equation multiplied by 5, make it 10x squared minus 15y squared equals 15. Then the y's will eliminate. I'll have 19x squared equals 57. Right? Is that okay? Which again, not too terribly difficult of an equation. What did I do there? Saw that.
19 squared.
Divide by 19, so we got x squared equals, that's just 3, isn't it? 3. Then, use our little square root method. There's actually two answers there. It'd be plus or minus square root of 3, wouldn't it? Now, good news, bad news here. Yeah, there's not an easy one to figure out the y there that I would call easy, but good news is we're squaring that. I mean, you could round it off to a decimal, but since I'm squaring a square root in either case, let's just plug it in here. And the other thing is, it's not going to matter if I plug in a plus or a minus square root of 3 there. It's not going to matter one bit. I'm squaring it, so the square and the square root cancel, and I'm squaring a positive or a negative, and so it's still always going to be a positive. Long story short there, either case I'm going to get positive 3. When I plug in a positive or a negative square root of 3 here, that's going to come out to be just 3. Because you square it, gets rid of the square root and all that. So you can plug it in separately if you want, but either way I'm going to get 3 times 3 at that first, which would be 9, plus 5y squared equals 14. Now just solve for y, so subtract the 9, divide by the 5, that works out pretty good. Y squared equals 1. So again, y would be plus or minus square root of 1, which is just plus or minus 1. Now, question for you, how many is that? How many solutions is that? That's 4 solutions, yeah. Because I've got square root of 3 with the plus or minus 1. And then I've got negative square root of 3 with a plus or minus 1. So that's 4 solutions. All written out would be that way. You could condense it too if you like. Okay? Is that all right? Any question? That was a little bit trickier. All right.
Now, anytime we get a square root, are we going to have more than one solution like that?
It depends. It depends. I'll do one where we look at why we have it, what we do. This, yeah, those are pretty complicated graphs. We haven't talked about the graphs of those yet. We'll talk about those later, but I'll get to a graphing one here in just a second. But yeah, you still could have, typically you do have more than one, to answer your question, yes. But you could still have just one, you could have none. They don't intersect, you know.
Could we write the solution as one group?
Yeah, if you want
plus
to
or
condense
minus?
it, I would be okay
Okay.
with that, yes.
Okay.
All right, a couple more here. This, x squared plus y squared equals 45. And then x minus y equals 3. Couple of points on this. X squared plus y squared equals 45. X minus y equals 3. Now, this one is not a good candidate for elimination. Do you see why?
These are squared in.
Yeah, we don't have, they're not matching up. We got an x squared and an x, we got a y squared and a y, and making those match up, that makes it even a bigger mess. So hopefully there you see, elimination, probably not the way to go on this one. Substitution is, and so this one, again, we worked one earlier where we had to do this. So to use substitution, I need one of the equations solved for one of the variables. We need one of the variables on the side by itself. And so it looks like the equation to start with is, of course, the second one. Solve that second one for either x or y, and it looks like x would be the easier way to go for that. So yeah, I'm going to solve the second one for x. And not hard at all, right? Just add the y to both sides, add it over. So then I can substitute. Take this, y plus 3, and substitute it for the x in the first equation. And what does that give me? Well, it gives me y plus 3 squared plus y squared equals 45. Which is not too bad of an equation, but a little more complicated than we've seen previously. How do I do that? My suggestion is, let's go ahead and square out the y plus 3. Write the y plus 3 twice, because it is FOIL there. Y plus 3 squared is y plus 3 times y plus 3. So I've got to FOIL that out one way or another. Y squared plus 3y plus 3y plus 9. Now don't forget the other one that's with that. You got still the plus y squared equals 45. Okay? With me there? All right, so what do we got? 2y squared plus 6y plus 9 equals 45. Well, looks like we're in the same boat as a couple of examples ago. I need to make one side 0. I've got a y squared equation like this. So I need to make, in these cases, I need to make one side 0 and then figure out from there. So let's subtract the 45. And so we have 2y squared plus 6y minus 36 equals 0. And it's happened a couple of times. I don't know how often it'll happen on homework or anything, but you can see it. Divide off that 2 there. Makes it a little easier. That's y squared plus 3y minus 16 equals 0. Yeah, that factors. Y 6 and 3, positive 6 minus 3. And so that's y plus 6 equals 0, y minus 3 equals 0. So that's y equals negative 6 and y equals 3. But again, that's only half of the answers. I still need the x, and again, now the point to be made here is if I plug in, just think about the y is 3. If I plug in y to be 3 there, how many x's do I get? I would get 2, wouldn't I? But I actually only get 1 because in the second equation I only get 1 x if I plug in the y here. So, be sure to check that out. Don't get too many solutions. Can't go overboard there. Yeah, there's just 1 x that goes with the y because of the second equation. The x here would be y plus 3, so it would be negative 6 plus 3, so that's negative 3. And here would be x equals 3 plus 3, so that would be x is 6. So I just had those 2 solutions. Negative 3, negative 6 is the x first, and then x is 6, y is 3. 2 solutions. All right? Okay. Well. y equals 8 minus x squared, and y equals 8 minus 2x. Well, this one's actually similar to a couple of them we did not too long ago. And yeah, this one, either method is okay. If you want to use elimination, I would probably myself go with substitution, but elimination would work just fine because I could get the y's to cancel out if I did that by -1 or something like that. But I think let's just do the substitution since we got y is 8 minus 2x in the bottom one. I can plug in that 8 minus 2x for the y in the top one, right? Which leaves me this, which again is an x squared equation. It's not going to be square root method, so I need to make one side 0. I would probably bring these over since the x squared is minus over there, so I would probably bring these over first. Make this right side be 0. Get rid of those. Well, 8 minus 8 is 0. So this side I've got x squared minus 2x, don't I? And then that just factors as x times x minus 2. And that's x equals 0. X minus 2 equals 0. And so we add 2, we got x is 2 and x is 0, which sets up y to be, well, y would be 8 minus 2x, so it'd be 8 minus 2 times 0, so that's y equals 8. Or, the other case, x is 2 would be 8 minus 2 times 2, which would be 8 minus 4, y is 4. So 0, 8, and 2, 4. Now, the reason I bring this one up is to talk about why is there two solutions here? Well, if we look at the graph of this, these equations, see if we can figure this out. What is that top equation? Y equals 8 minus x squared. So second degree quadratic equation. What shape do those have? Parabola. So I got a parabola here. And it might be a little more familiar if I switch those around. It's minus x squared plus 8. So isn't that the x squared equation flipped over and up 8? So it's x squared flipped over and then up 8. So it kind of gives you an idea. You know, if you get some points, you got your y-intercept is at 8. You know, just do, you have to, a little table or something like that, but kind of know what it should look like. But to get a little bit nicer, let's get the -1 points, positive 1. If we do positive 1, might be easier. That'd be, now I'm just squaring the x, so it'd be -1 plus 8, which would be 7. I don't square the negative on that. Now, with the -1, I square the -1, but then I negate it, so it's still 7. Anyway, kind of gives you a couple of points to get there. Get more if you need it. Something like that. And then I have 8 minus 2x. Well, that's just a line. Minus 2x plus 8 again. Maybe a little more familiar. So yeah, there's our y-intercepts 8 down 2 over 1. There we go. I didn't do a good job hitting my point though. So You got your 0.8, and you got your 2.4. Two intersections. So it makes sense that this would have two different solutions there. How's that? Anything talk about there?